In Java, not all nested classes are the same. Some are static, and when they're not static, they get the special name of inner classes. This is more in this video. Hi, Marcel from Jectus. I have the following Java file. It's a top-level class named outer, which declares a static nested class called nested. Let's compile this Java file. The compilation generated two class files, one for the outer class and another for the nested class. We can see that apart from the class name, they are basically the same. To be sure, let's check the verbose output. And the only difference really is the class name. And we can see that the code for the automatic constructor get is the same. So a static nested class works the same way as a top level class. It just happens to be defined in another class. For me personally, it has two main use cases. First one is namespacing. A SQL session is distinct from a web session. Just like a Java util list is different from the list from EWT. The second one is specifying different access levels to the nested class. A top-level class can only be either public or package private. A nested class, on the other hand, does not have this limitation. It can have any of the four access levels. Right, I've changed our outer Java file to the following. Now the nested class is not static and it's called inner, meaning it's an inner class. Let's compile this Java class and inspect with JavaP. Once again, it produced two different class files, one for the outer class and another for the inner class. And we can see that the constructor signatures are different. In the inner class, it has a parameter of type outer. Right, I've changed the outer Java file to the following. The outer top-level class now declares a method named say, which prints the message to systemout. And the inner class has a method named sayHello, which invokes the same method from the outer class with the hello argument. Let's compile this Java file and inspect the class file with JavaP. You can see now that our inner class has an additional field of type outer. And when we look at the code using the -c option, we can see that our sayHello method invokes the same method from the reference it gets from the constructor. And when we look at the verbose output from JavaP, we see that the field has the syntactic flag. So when JavaC compiles this Java file, it creates two class files which are equivalent to these top-level classes. Notice the parameter in the inner class constructor. And when JavaC compiles this Java file, it generates two class files which are equivalent to these top-level classes. And notice once again the parameter in the constructor, which initializes the outer field. And our sayHello method invokes the say method using this reference. So the takeaway is, to create an instance of an inner class, we must first provide an instance of the outer class, as required by the constructors. And how do we provide the outer instance? And please note that here we're talking at the language level, not at the class file level. First, we create an instance of the outer class. Then we use a qualified class instance creation expression. Here it's qualified with an expression name, meaning this local variable. And here it is qualified with a primary expression, which is a class instance creation expression. Or if we're already in an instance of the outer class, we simply create an instance of the inner class. So there's no need to qualify the new expression. Though if we really want to, we can we can still qualify the class instance creation expression. In this case, once again, with the primary expression, which is in this case the this keyword. And what are use cases for inner classes? I personally use inner classes a lot. I actually use local classes as well, quite a bit. But anyways, here's a snippet taken from the ArrayList class. The list iterator is implemented by an inner class. And why? Because it can access the state from the outer class directly. For example, the hasNext method from the iterator checks the cursor from the inner class against the size instance variable declaring the outer class. Cool, right? I hope you enjoyed this video. I hope you learned something new and interesting. And that's it. See you next video. Bye.